It's a nightmare scenario.
This would be more than millions of Hiroshima bombs going off all at once.
The world is hit by the biggest natural disaster on the planet. A super eruption.
It would be just as bad or maybe even worse than an asteroid impact.
Power networks destroyed. Entire cities lost beneath ash.
It would be heavy enough and thick enough that it would crush people and animals alive.
The sun dims across the globe.
It would impact the entire planet, economies, weather, everything.
The Earth is plunged into a winter that lasts years. Harvests fail.
Right now, we have about 3 months of grain stored, and after that, there will be no food.
We would be looking at widespread famine.
Could this nightmare really happen? To investigate this potential cataclysm, we will use the latest scientific data to uncover the danger beneath us as we see our planet like never before. If the apocalypse came, this is where it would start.
It's a gorgeous day. I'm really excited to be here. I love coming to Yellowstone. Yellowstone is one of the most incredible places in the world.
Spanning 3 states, Yellowstone lies in the heart of America's Rocky Mountains.
One of the reasons Yellowstone's is such a spectacular place to visit is because it's an exotic landscape full of boiling mud pots, steaming hot pools, and geysers.
Including the world-famous Steamboat, the tallest active geyser on the planet, blasting boiling water over 300 feet high. But there is another Yellowstone, one that only scientists get to see. Our X-ray view reveals a network of water channels flowing under Yellowstone, filled with snowmelt from the mountains. But this snowmelt is boiling hot.
There's so much heat coming out of the ground here. The question is, why? Why do we have so much heat?
The first clue to the park's mysterious heat source lies over 3,000 miles away. In another place, famed for its geysers and hot springs.
I've been living in Iceland for the past 20 years, studying the activity here.
Ricky Pedersen is one of Iceland's leading geologists. Just like Yellowstone, this island churns with steaming vents, mud pots, and geysers.
Geyser is actually the original Icelandic word for a gusher. So it gushes hot water onto the surface.
But unlike Yellowstone, in Iceland, the source of the intense heat is plain for all to see.
We see the steam rising, we see the bubbling mud created by the fact that we have molten magma just a few kilometers beneath our feet.
Iceland was built by volcanoes. Smaller than most US states, Iceland has over 100 volcanic sites.
The black landscape here is really the evidence of the very volcanic, dynamic environment in Iceland.
Every 4 or 5 years, a volcano wakes up.
The volcanic source of the geothermal system here is evident. All of Iceland is created by volcanism. There's nothing here which is not originated from a volcano.
Geysers in a land of volcanic mountains. And geysers in a land without them. You don't see black lava fields in Yellowstone. Yet this one park has more than 10 times as many geysers as all of Iceland. Where is all the heat coming from?
One of the really great things about working in Yellowstone is it's so dynamic. Every time you come here, you see something new, you see something different. There's always a new question, there's always a new problem. Keeps it really interesting.
Jamie Farrell has spent more than a decade studying what lies beneath Yellowstone. To find out more about this huge and unpredictable system, he deploys a network of ground sensors.
A couple pieces of equipment here. This is what I use to talk to my seismometer. And then here I have the actual seismometer, and what it does, it just measures these really slight vibrations of the ground. We record these seismic signals for the purpose of finding out where they're coming from. What does the plumbing system look like under the ground? Why is it so active right now?
Seismic data builds a 3D image of the ground under Professor Farrell's feet. Using this data, we can X-ray the Earth to show the source of Yellowstone's extraordinary heat. Beneath the park's geothermal system, scientists discovered a spectacular sight. A vast chamber of semi-molten rock extends beneath around a quarter of the park. 55 miles long and 25 miles wide, it's one of the largest magma chambers yet discovered. Scientists believe it's more than twice the volume of the Grand Canyon. In Iceland, magma chambers a fraction of this size power violent volcanoes. Yet on the surface of Yellowstone, there's almost no sign of the monster magma chamber beneath. Why? The answer can be found along one of the most volcanic regions on the planet, the Ring of Fire, a deadly chain of volcanoes circling the Pacific Ocean.
I've been coming to Indonesia for about 6 years to study the amazing geology that we find here.
Geologist Dr. Adanara Mutsek is an expert on Indonesia.
We have over 120 active volcanoes.
One of Indonesia's most active volcanoes is Mount Sinabung on Sumatra. It's hit this island with devastating eruptions for the past 9 years.
Selamat pagi.
Ya, selamat pagi. Apa kabar?
Dr. Mutsek is right at home at the Sinabung Volcano Observatory.
Wow, so this is the actual ground movement readout from the eruption on the 9th of June this year. It is incredibly active. Oh wow, it's very clear.
Ya, clear bersih.
Standing here today, you see such an impressive looming volcano, and you realize the danger behind it, and yet the sun is shining, the birds are chirping, it doesn't feel that dangerous. It's kind of like playing with fire. The most recent eruption, there was a ash column plume that was about 7 kilometers high, and pyroclastic flows that actually encompassed this whole region here that we're looking at of Sinabung.
Pyroclastic flows, avalanches of boiling rock, ash, and gas. Far more dangerous than a lava flow, they can move in excess of 400 miles per hour. And they stamp a volcano's mighty footprint for miles around. In territory near the volcano, Dr. Mutzek finds pyroclastic deposits. But there's a mystery. There's way too much material, even for Mount Sinabung.
That means there's a volcano somewhere around here that is hundreds of times bigger than Sinabung.
Where is the mammoth hidden volcano? And can it explain why the peaceful Yellowstone could one day turn into a mass killer? Clues to the mystery behind Yellowstone's benign appearance lie on the Indonesian island of Sumatra.
So we've left the observatory and we've headed south into the Sumatran forest. And what I'm looking for is eruptive material.
Volcano expert Dr. Adanara Mutzek hunts for evidence of Indonesia's deadly eruptions.
This particular site looks like a good place.
From a patch of exposed rock, she digs out a clue.
These lines appear to be fibrous glass, which would mean that it's actually from magma that's been sort of stretched and then rapidly cooled to form this sort of texture that we see. The name that we give this type of eruptive material is ignimbrite. And ignimbrite is actually formed from really large pyroclastic flows.
Dr. Mutzek is in the shadow of Sinabung, a recently active and highly dangerous volcano.
So you might think that this ignimbrite came from Sinabung. However, there's a problem. Sinabung is not a big enough volcano to have produced all of this ignimbrite. This ignimbrite is really thick and covers an extensive area. In some places, the thickness of this ignimbrite is over 300 feet. What we see here is just the tip of the iceberg. And that means there's a volcano somewhere around here that is hundreds of times bigger than Sinabung.
But where? Indonesia has no volcanic mountain even close to 100 times the size of Sinabung. Could a giant volcano be hiding in plain sight? The riddle takes Dr. Mutzek further south to a massive body of water nearly 20 miles wide and 1,500 feet deep. Lake Toba. In the center is the island of Samosir. Here, mammoth cliffs tower more than 2,000 feet high. But the rock at the very top is not what you'd expect.
The material we find at the top of these cliffs are actually lake sediment, and lake sediment would have originated from underneath the lake.
How did rock from the lake floor end up thousands of feet in the air?
It would mean that something would have pushed these lake layers up through the lake and above the lake to these great heights. And geologists have found that this force that's pushed the ground upwards to form this island is magma.
Like at Yellowstone, beneath these waters lie vast quantities of magma. 74,000 years ago, a colossal eruption blasted out in a ring. The volcano collapsed on itself, creating the enormous crater called a caldera. Then, over thousands of years, restless magma pushed up the telltale island in the center.
If you're looking for the volcano, this is it. We are in it right now.
Lake Toba is the volcano. A mammoth caldera like this is the signature of the most powerful natural disaster on Earth, a super eruption.
The strength of a super eruption would be more than millions of Hiroshima bombs going off all at once. Everything within a radius of around 200 miles was completely incinerated.
A super eruption, a super volcano. Today, Toba hides its cataclysmic history because the eruption was so big, the volcano destroyed itself. Like Toba, Yellowstone sits above vast stores of magma. Could Yellowstone be a supervolcano? If it is, where's the caldera?
Lake Toba is a classic example of a caldera. So when we're thinking about super eruptions and evidence for super eruptions, we would expect to see a similar caldera here at Yellowstone. But when we look around, we don't see an obvious caldera.
On the western edge of the park lies a clue, a sheer cliff.
These cliffs tell us two things. One, certainly lava has erupted here, so they're volcanic. But even more interesting is why it's a cliff. Lava flows aren't going to form a cliff face. Something had to have happened to expose this lava. Something really big. The ground where we stand at one point would have been up at the top of those cliffs. And it would have catastrophically dropped down to expose what we see today. And the only way that can happen is in a super eruption. So these cliffs are really good evidence that we may be on the edge of a caldera. But the next question then is, where's the rest of the caldera? When we look around Yellowstone, we don't see an obvious depression. So where is it?
To solve this puzzle, we need to peer hundreds of feet underground. Using data from rock samples gathered across Yellowstone, scientists can build up an X-ray view of what lies beneath. A vast crater more than 6 times the size of Chicago. A hidden caldera.
So Yellowstone does have a caldera. And from this vantage point, we can see why it's so hard to see it. The first reason is because it's absolutely enormous. It's 32 miles across. The second reason is this ancient caldera has been almost completely filled in. This proves that Yellowstone is a supervolcano.
The power to unleash a global apocalypse lies right here. Could the sleeping giant ever wake up? The remote wilderness of Yellowstone is also a supervolcano with the power to threaten U.S. cities from San Francisco to Chicago. What could push Yellowstone over the edge?
So I first came to Yellowstone, like many people, on a quintessential American road trip when I was a kid, long before I knew I'd be a geologist.
To investigate the mechanics of Yellowstone's eruptions, volcano expert Christy Till digs into its violent past.
Now this looks promising. To get a bit closer, it looks even more promising. Yes. This is exactly what we're looking for. This is a beautiful eruptive deposit. I see horizontal layers, a very consolidated layer up here. This would be what we would call a welded ignimbrite.
Ignimbrite, a 50-cent word with a megaton punch. And it's the same material piled high around Indonesian supervolcano Toba.
There's over 1,000 cubic kilometers of this ignimbrite all over Yellowstone. We see cliffs of over 400 meters of it.
Avalanches of boiling ash once raced across the land.
You would not want to be anywhere near Yellowstone at the time that eruption.
Dating the Yellowstone ignimbrite reveals a supereruption from 630,000 years ago. But that's not the only remarkable fact hidden in the rocks of Yellowstone.
When we look at those dates, we see 3 different dates. We see 3 different timestamps of 3 different eruptions. So there were 3 gigantic eruptions at Yellowstone, including this one. That just blows my mind.
Yellowstone didn't just have one huge eruption. This is a serial supervolcano.
It had the first of its super eruptions about 2.1 million years ago. Then another eruption about 1.5 million years ago. And finally, its most recent super eruption about 0.6 or 630,000 years ago. So each of those created a giant depression in the ground that subsequently filled up with lavas that were erupted afterwards, and then the cycle started all over again.
Is Yellowstone headed for cataclysm number 4? To find out, we need to see what triggers volcanic eruptions.
Volcanoes are found in relation to the tectonic plates. They're at the plate boundaries between the plates, whether the plates are moving apart or coming together.
Professor Mike Rampino visits one of the few places on Earth where tectonic plates can be seen pulling apart on land.
We're standing here on the plate boundary, this rift that runs through Iceland, where the plates are diverging. They're being pulled apart. We're standing here on the European side, and that plate over there is connected to the North American plate. If you stood here long enough, you could actually see the plates moving. But they only move at about 1 centimeter per year, so you have to stand there for quite a while. And of course, there's volcanism, because as the plates spread apart, magma comes up from below.
95% of the planet's active volcanoes form at these plate boundaries. But Yellowstone doesn't play by the rules.
Yellowstone's really an anomaly because we're not at a plate boundary. We're in the middle of the North American plate.
The nearest boundary is over 800 miles away. So if colliding plates couldn't trigger a supereruption here, what could? With seismic data gathered across the United States, we can produce an X-ray view of what's happening beneath Yellowstone. The continental plate of North America floats on the Earth's mantle, a layer of semi-molten rock. In 2018, scientists discovered a 220-mile-wide anomaly in the mantle. A column of semi-molten rock believed to be hotter than its surroundings, rising from the interior of the Earth like a giant lava lamp. It's called a mantle plume.
Mantle plumes, because they're derived from so deep within the Earth, they can come up anywhere. They don't have to be centered at tectonic boundaries like most of our volcanoes. They can occur anywhere in the middle of plates. And so here at Yellowstone, that's exactly what's going on. You've got a mantle plume coming up from very deep and puncturing up through the crust.
A plume this vast could provide the ammunition for a doomsday eruption. But what could pull Yellowstone's trigger? Yellowstone National Park sits on dangerous ground. X-ray views of the Earth reveal a vast magma chamber capable of inflicting disaster on the planet. How restless is this colossal source of power?
We work all year round in any conditions. Today we're having a nice fall day, rain turning into snow and sleet. We come here in the winter, summer. Winter's my favorite, but more challenging. There's a lot of snow. Got to use skis and snowmobiles to get around.
In a remote corner of Yellowstone, scientist David Menson tracks the magma's behavior.
We're here to measure the ground movements, how the ground is reacting to the magma chamber underneath in order to determine what it's doing. And we're going to use a GPS equipment, the same kind of equipment that's in your phone, but a much higher grade where we can get millimeter level precision. And then we have a GPS antenna. It measures the distance between the GPS satellite and the antenna. And we measure the change in position of the antenna over time, and that tells us how the ground is moving over time, and therefore tells us how the magma chamber is changing over time. We've learned that Yellowstone is moving up and down. So parts of the park are moving up and parts of the park are moving down. A whole area of 10 kilometers will go up, 10 centimeters, or in this area next to it will go down. So what that indicates to us is that the volcano is restless. It moves. What that means is that there's magma or fluids moving around beneath the surface. Despite its appearances, Yellowstone is an active volcano, and in fact is the largest active volcano in the world.
But what would tip the Yellowstone magma chamber into another eruption?
The way these magma chambers work is very different than that boiling hot cauldron of magma that you might imagine is below a volcano. In fact, many of these magma chambers are mostly crystallized. Think about a slushie. When you first get a slushie, it's mostly ice, and you can't drink it through a straw. You need it to warm up a little bit over time so that there's more liquid that you can drink through the straw along with that ice.
What would it take to go from geological slushy to super eruption?
Something would have to happen. We need to have a new flux of magma into the magma chamber to warm it up, to get it to be more liquid, more than 50% liquid, to get it to erupt.
For now, the data suggests no more than 15% of the Yellowstone magma chamber is liquid, far below the 50% tipping point. How fast could things change? Geologist Hannah Shamloo hopes to answer this big question by finding something very small.
Here we're looking at a package of ash from Yellowstone's most recent supereruption. One of the most exciting parts of this ash are the crystals that are contained within it. And I can already see some very large, nice crystals. These crystals are like time capsules of information. What was happening beneath the volcano before it erupted?
Slicing the crystals reveals layers of growth over time. Like tree rings, these layers record what was happening in the magma chamber, right up to Yellowstone's previous super eruption.
What we think happened is that an injection of fresh, slightly hotter magma entered the reservoir and basically caused the magma to be a little more liquid and more eruptible, ultimately leading to its eruption. We really had no idea how long these processes took. Millions of years, hundreds of thousands of years.
But the research revealed a very different timescale.
What these crystal rims are telling us is that from the point of injection to eruption takes no more than a few decades. What we're finding is that they happen on the scale of a human lifetime.
The discovery doesn't make a super eruption any more likely, but it does mean if the magma started to move, Yellowstone could turn deadly far more quickly than we knew. Yet that would need an injection of large volumes of molten material into the magma chamber. Where could it come from? In 2015, Jamie Farrell and his colleagues were making seismic scans deep beneath the Yellowstone magma chamber.
What we're looking at here, this is a cross-section through the Yellowstone caldera. On the top of this image, we have the magma reservoir, which we've known for quite a while now. It's already one of the largest magma reservoirs that we've seen on the Earth. But, immediately below, we see this kind of orangish, reddish area. This feature has never been seen before.
Incredibly, beneath Yellowstone's magma, the scientists had discovered a second mammoth chamber, 4.5 times bigger. In a worst-case scenario, this far larger store could inject magma into the upper chamber, pushing it over the edge. Nothing suggests the supervolcano will go off anytime soon. But we know it detonated on an epic scale 3 times before. If Yellowstone did erupt again, how catastrophic would it be? In 2010, Professor Mike Rampino saw the volcano Eyjafjallajökull blow its top.
We were up in a helicopter filming the eruption. You could see the plumes of ash. You could feel the shockwaves from the explosions. You could see huge blocks being thrown out of the volcano.
Ripple effects spread across Europe. Air travel was shut down.
The ash is like glass, and as it's taken into the jet engine, it's melted. And then it coats the inside of the engine and blocks the jet, and then the engines turn off.
More than 95,000 flights were canceled. Yet this was a geological blip compared to the ancient super eruptions of Yellowstone.
Eyjafjallajökull was a very, very small eruption, less than 1 cubic kilometer, mostly ash. And Yellowstone, we're talking about more than 1,000 cubic kilometers.
An ash cloud from Yellowstone wouldn't just ground aircraft or just hit nearby towns like the 1980 eruption of Mount St. Helens. It would blanket more than half the country. What would this mean for people and animals?
The great thing about this place is it's incredibly well preserved, so you can really see all of these amazing clues to paleoecology of ancient Nebraska and some really interesting clues about volcanic eruptions of the past.
Paleontologist Dr. Megan Wetherill visits the scene of a cataclysm, looking for answers.
It is immense. There's just skeletons everywhere. This is a whole bunch of dead animals, which should be theoretically sad, but as a paleontologist, this is riveting stuff. You never get stuff like this.
12 million years ago, when these animals died, Nebraska looked like Africa. This site was a watering hole.
The first thing that really catches my eye out here is this enormous rhinoceros skeleton. There's a little one that is next to it, and this is a baby. This looks like a really beautiful, touching moment. In actuality, this is a death moment, a moment where this calf and this mother died together. There are many, many others. In fact, there are so many full skeletons. This is what you would call a death assemblage.
All these animals died within weeks of each other. But what killed them?
You can see all over this rhino bone, there's this bumpy, really frothy looking texture. That's not normal. This is normal. This is diseased. And the answer here is probably hypertrophic osteopathy or Marie's disease.
Marie's disease usually results from severe lung damage.
The culprit is probably the same thing that actually buried these animals. It's ash. They're coming out of a foot-thick bed of ash that covers a huge swath of Nebraska.
12 million years ago, this ash choked them, killed them, and buried them. It came from an ancestor of the supervolcano beneath Yellowstone. A supereruption in the U.S. today could wipe out up to 20% of all Americans. Disaster would spread across the globe, judging by an event just 200 years ago.
1816 is very famous in history as the year without a summer. It snowed in the eastern United States in July and August. Frost killed the crops. In Europe, there was famine.
Food riots broke out around the world. More than 82,000 people died, many from starvation, all thanks to a volcanic eruption the year before.
A volcano called Tambora in Indonesia. One of the biggest in historic times.
How did an eruption on the far side of the Earth create a year without a summer in Europe and America? It wasn't the ash cloud, but tiny particles belched out by Tambora.
Sulfur dioxide is interesting because when it gets into the upper atmosphere, it combines with water and makes little droplets of sulfuric acid. And that builds up in the atmosphere, forms a veil. And so it cuts out the sunlight.
Sulfuric acid from Tambora dimmed the sun across the world for a year. And this wasn't even a super eruption. Yellowstone's eruptions were at least 10 times more powerful than Tambora.
For something like Yellowstone, the cooling was, on a global basis, maybe 5 degrees or more. And 5 degrees, it doesn't sound like a lot, but that's the difference between now and an ice age.
A global volcanic winter that lasts years.
Imagine a world with no growing season, maybe several years without summers. Crops failing all around the world. And right now we have about 3 months of grain stored that would feed the world for 3 months. And after that, there would be no food.
Humans weren't around for Yellowstone's last super eruption. If there is another, what would happen when a civilized world met a volcanic juggernaut? Simmering beneath Yellowstone National Park are 2 of the biggest magma chambers yet discovered on Earth. The worst-case scenario, a super eruption. These events are utterly devastating, but incredibly rare.
The probability in any given year is 1 in a million. So it's improbable in our lifetime, but it's something that will happen.
In our lifetimes, it may be a 1 in a million chance, but Yellowstone is going to erupt again.
It's important that we understand these things because we know they've happened in the past, and they can very well happen in the future.
What we can say about it, though, is that we would have some warning. We would get on the order of a decade or decades of warning.
So what would it look like if the worst-case scenario played out for real? Around 20 miles beneath Yellowstone, the Mammoth Magma Store begins to heat up and inject molten material into the upper chamber.
We would know. There'd be certain special kinds of earthquakes and ground deformation from that magma that was moving in under the volcano.
It could also manifest itself in increased gases coming out of the hydrothermal system.
As the upper magma chamber reaches its tipping point, the Yellowstone supervolcano gets ready to blow.
What we understand now is that these eruptions, we get all these warnings, but then when they do actually occur, they occur very quickly. A caldera-forming eruption, which humans have never seen, is on the scale of like a meteor impact. It would impact the entire planet.
As the super eruption intensifies, 240 cubic miles of material would be hurled upwards, reaching halfway to outer space. But what goes up must come down.
As that column builds and builds and builds and gets heavier, it eventually gets too heavy to support itself, and it starts falling back down to the Earth. And that's where we get what we call pyroclastic flow.
Traveling at up to 400 miles per hour, burning at nearly 2,000 degrees Fahrenheit, nothing in their path would survive.
Anything within a 100-mile radius of Yellowstone would be completely wiped out.
It would be like wiping out the peninsula of San Francisco in just a matter of minutes.
Those who escaped the boiling avalanches wouldn't escape the thick, toxic ash. It would rain down for weeks.
Ash would blanket the United States.
Within 200 kilometers of the crater, scientists estimate it would be heavy enough and thick enough that it would crush people and animals alive.
Highly charged dust would short-circuit power lines, destroying the electricity grid, plunging the country into darkness. Daily life would grind to a halt.
Air travel is going to be shut down in huge swaths of the world, not just in the continent.
While America choked, disaster would encircle the planet. Billions of tons of sulfur dioxide would send global temperatures plummeting.
The big thing is they pump a lot of material and gases up in the upper atmosphere. You don't necessarily get dark, but it just gets really cold, and then crops fail.
We would be looking at widespread famine due to crop loss. Would almost be unfathomable.
Earth would be in the grip of a 5-year global winter. Within years, millions would starve.
It wouldn't be a mass extinction event, but it might be a civilization-ending event. The famine, the civil unrest, wars that might break out, disease, all those things would happen in the aftermath of the supervolcanic eruption.
Humanity's saving grace is that super eruptions are uncommon events.
They're incredibly rare. But even though they're very rare, it's still important to understand what the effects of such an eruption might be. It's really just something that, as a geologist, I hope does not happen in our lifetime.